How do you identify an endothermic reaction for GED Science? Have you ever noticed how ice feels cold when you touch it? That's a hint about endothermic reactions. So, how do you identify an endothermic reaction for your GED Science studies? Let's break it down in a simple way. An endothermic reaction is one that absorbs heat energy from its surroundings. When this happens, the temperature around the reaction usually drops. This means that the reaction is pulling in heat instead of releasing it. To spot an endothermic reaction, keep an eye out for a few key signs. First, if the reaction mixture or the area around it feels colder, that's a strong indicator. This cooling effect happens because heat is being taken in by the substances involved in the reaction. Next, think about heat as a reactant. In endothermic reactions, energy is needed for the reaction to take place. This is different from exothermic reactions, which give off heat. Another important detail is the enthalpy change, which is often represented as the Greek letter delta followed by H in endothermic reactions. This value is positive. This means that energy is absorbed during the process. You can also look for physical changes that are endothermic. For example, melting ice is an endothermic process. Ice absorbs heat to change from solid to liquid, which cools the environment around it. Evaporation of water is another example. When water turns into vapor, it absorbs heat from its surroundings. This is why you might feel cooler when you step out of a pool on a hot day. Dissolving certain salts like ammonium nitrate in water is also an endothermic reaction. When this salt dissolves, it absorbs heat, making the solution feel cold to the touch. In the context of GED Science, understanding these reactions is essential. Recognizing that energy must enter the system for the reaction to occur helps you differentiate between endothermic and exothermic reactions. So, to identify an endothermic reaction for your GED Science exam, remember to look for signs like a drop in temperature, a positive enthalpy change, and the need for energy to break bonds or change states. These characteristics will help you distinguish endothermic reactions in both physical and chemical processes.